Hello everyone, in today's session we will be having a brief overview of Ansys Workbench. We will learn about what is Ansys, what is FEA. FEA stands for Finite Element Analysis and is the main concept behind the working of Ansys. We will learn about what is Ansys Workbench and have a brief introduction to its different component. And at last we will solve a basic example. So what is Ansys? Ansys is a software package that lets you digitally model a real world phenomena. It uses computer-based numerical techniques to solve problems that are not amiable to an analytical approach. And this whole thing is made possible with the help of FEA or CFD packages. So now question arises, what is FEA? So FEA stands for Finite Element Analysis, and Finite Element Analysis is a way to stimulate loading or basic conditions on a design and determine the design's response to those basic conditions. The design is modeled using discrete building blocks called elements. So the basic theme behind finite element analysis is to divide the domain, or in our case, the surface or volume, into smaller parts or so-called elements, which are connected to distinct nodes. Hence, we make calculation at finite number of points and then interpolate the results to get the same result for the whole surface or volume. Now the next step is Ansys Workbench. So Ansys Workbench is our user interface on which we work. Ansys Workbench is a new generation solution from Ansys that provides powerful method for interacting with Ansys solver functionality. This environment provides a unique integration with CAD system and your design processes, enabling the best computer-aided engineering results. Now let us look into the different components of Ansys Workbench. So for this we should move to the software. This is what our Ansys Workbench looks like. Under this user interface, we have a menu bar which contains different sections like File, View, Tools, Unit Extension, etc. Now we have File section. From here we can save, import, archive our ongoing projects, form a new project, or open an already existing one. Under the View section, we can customize how our user interface will look. Tool section helps us to update or refresh our project. Unit section administers the unit that are being used in our project. In fact, we can choose and alter the unit system by clicking on unit systems. Here we can see that there are three tabs, B, C and D. B represent the unit that are being used in our project, C refers for default, and D, the ticked ones, refers to the ones that are not being showed in the unit section. In fact, we can change these as per our accordance. Now, the extension system gives us additional features, and by going on help section we can solve our doubts or any problem that we have. After the menu bar we have a project view. When we open a new project, it opens up under the project tab. Project tab contains a toolbox which have different type of systems and a project schematic. And now describing the different type of systems. So under the toolbox, we have analytics system, component system, custom systems, design, exploration, and ACT. And analysis system includes all the component needed for our analysis, such as geometry, mesh, solver, etc. Whereas the component system are individuals. Component system contain all the individual component required for analysis separately. With the help of component system, we can develop a custom analysis system as per our requirement. And in case we save these custom system, these will be shown under the custom systems. Design exploration provides us with tools for design optimization after we have done our analysis. Now let us take a small example to see how Ansys Workbench operates. We can either choose a random analysis system that already contains all individual component, or we can build our own custom system with the help of component system. In fact, in case you want to use same inputs for two analysis system, we can achieve it with the help of component system. For using any of these systems, we just need to drag it to the project schematic. The same result can be obtained with the help of double clicking also. Now, for example, we want to build our own custom system. We should start with the geometry. We can link it with the mechanical model. Now, if we want to link analysis systems with it, we can simply drag the analysis system to model, and we can see that here share C2, C4. This means that the data of these three individual systems, that is engineering data, geometry and model, will be shared with static structural analysis system. If we want to operate on the same input for two systems, we can simply drag the other system to and share the same data with it. Now this square means that if we update the data in the first B section, that is geometry, which is linked with C and further with D and E, the same geometry will be used in all of these. Now for our example, let us choose a static structure. And as you can see with these drag, we can delete, update or duplicate these systems. And let us delete. As we have chosen a static structural as our system from the toolbox, we can either drag it directly or double click it to achieve the same result. Now, this system already contains all the individual systems such as engineering data, geometry, model, solver, and result, etc. Now we can see that there are different type of signs. The stick means that the data is already uploaded. Question mark means that we need to edit and upload the data. Now the engineering data administers the material that is being used in the project. By double clicking it, we can choose and alter the material and its property as per our requirement. Here we can see that a structural steel is the material that is being used and these are its properties. Now by choosing engineering data sources, we can choose material of our choices. For example, if we need a general material, we just need to click it here and we will get a list of all the general material present. And by clicking on the plus sign, we can add it to our inventory. In fact, we can also change its values by its properties by clicking it here. Now we will be using the structural steel for our example. Now in geometry, we can either make a new geometry with the help of a space claim geometry or import our already existing one. So we will be importing our geometry. Now you can see that we have got a tick, which means that the geometry has been uploaded. This sign means that update, it needs update. The model is responsible for mechanical interface. Now by double clicking it, we are starting the mechanical interface. As we can see on the bottom side, it's reading the starting mechanical. This is our mechanical interface. As we can see, the geometry has already been imported to our system. The model portal contains geometry, material, coordinate systems which have been already decided. Now we need to update our mesh. By right clicking on mesh, we can click on generate mesh. Now Ansys is generating our mesh. Ansys generally generates a default mesh and I think this is pretty good for our example. But if you want, we can alter our mesh by right clicking on it and going to insert and on clicking sizing. By clicking on sizing, we can choose the size of these small elements as per our convenience. We will be going with this default system only. Now the static structural is responsible for boundary conditions. Now let us right click on it and by going on insert, we can make one of the faces as a fixed joint. Simply choose the face and here we can apply it. As you can see, one of the joint has been fixed support. Now on the next other face, we can simply apply a force. Click on apply and next we can choose its magnitude. For example, let us make it 100. The Ansys already chose a random direction for our force, but we can change it by clicking on click to change. We can choose a direction as per our convenience, but we will go with default only. Now coming to the fourth solution column. Solution column, here we can choose that what kind of solution we need. So let us go with deformation, total deformation, and we can choose stress, equivalent stress. And after you have chosen all the things that you need to be solved, we can simply click on solve, and Ansys will now take care of all the things and provide us with an appropriate result. As we can see a slight deformation in our geometry, and these colored region represent the maximum and minimum strain as per the table that is shown here. And by scrolling down on the bottom side, we can see all the results that has been updated. We can see the minimum and maximum stress that has been applied, the average stress that has been applied, in fact the positions also. And so, with this, our analysis is complete, and similarly we can perform different type of analysis on different geometries. So in today's session we learned about Ansys, what is FEA. We had a brief description of Ansys Workbench, and we went through its different component, and at last we took an example to understand the basic components of Ansys and how we can operate it on our project. I hope that this session was helpful. Thank you.